Welcome to the Regents Physics Current Electricity Problem Set, problems numbers 32 through 35. Number 32, a 75-watt bulb power is connected to a 120 volt source voltage. What's the current through the bulb? What's the resistance of the bulb? And then they put a lamp dimmer, variable resistor, puts a resistance in series with the bulb. What resistance would be needed to reduce the current to 0.3 amps? All right, let's go ahead. A is pretty easy. Using the power formula, P equals V times I. I would be P divided by V. So 75 watts divided by 120 volts, 0.625 amperes, 3 digits on that answer. For B, the resistance of the bulb, Ohm's law, R equals V over I. 120 divided by 0.625 amperes gives you 192 ohms to 3 digits. If you put the dimmer resistor in series with the bulb, that means the total resistance in series is the sum of the lamp, the bulb itself, and the dimmer resistor. They want, using Ohm's law, that total resistance would be V divided by I. So we have 192 ohms plus R2 equals 120 volts, and they want the current to be 0.30 amperes. So 192 ohms plus R2, 120 divided by 0.3 is 400 ohms. 400 ohms minus 192 ohms is 208 ohms. So the resistance would have to be 208 ohms for the current to be 0.30 amps. All right. Number 33, in problem 32, you found the resistance of a lamp and a dimmer resistor. Assuming the resistances are constant, find the voltage drops across the lamp and dimmer resistor, find the power dissipated by the lamp, and find the power dissipated by the dimmer resistor. For A, the voltage drops for each across the lamp, V equals I times R. 0.3 times 192 is 57.6. Across the dimmer resistor, V equals I times R, 0.3 times 208 equals 62.4. Note, when you add these two together, you should get 120 volts, the total. Okay, and indeed that's the case. For power dissipated by the lamp, P equals V times I. The lamp uses up 57.6 volts times 0.3 amps, 17.3 watts. For the dimmer resistor, 62.4 volts is used up times 0.3 amps, 18.7 watts. Okay? And notice what happened to the power of the bulb here, and therefore its brightness. It went from 75 watts, and now with a dimmer resistor in it, it's only got 17.3. That's the purpose of the dimmer resistor, is to use up some of the voltage, leaving less available for the lamp. You probably have some of these in your home. 34. A 16 ohm and a 20 ohm resistor are connected in parallel. A difference in potential of 40 volts is applied to the combination. Compute the equivalent resistance of the parallel circuit. What's the total current in the circuit? What's the current through the 16 ohm resistor? All right, for the total resistance of the parallel circuit, 1 over the total equals 1 over 16 plus 1 over 20. Common denominator, 16 and 20 is 80. So this would be 5/80ths plus 4/80ths, which is 9/80ths. So the total would be the reciprocal of that, which is 80/9. 80 divided by 9 is 8.89 ohms to 3 digits. For the total current, they want the total current, therefore you have to use total quantities to calculate it. So the total current is going to be the total voltage of 40 volts divided by the total resistance of 8.89 ohms. That will give you a total current of 4.50 amps. And lastly, current through the 16 ohm resistor. It's a parallel circuit, so all devices get the total voltage that's available in this case, which is 40 volts, divided by 16 ohms. So I equals V over R, and you get 2.5 amperes. All right, and lastly, 35. A typical television dissipates 275 watts when it's plugged into a 120 volt outlet. So we have power and we have voltage. Find the resistance of the television. What's the equation that relates power, voltage, and resistance? P equals V squared over R. Therefore, R equals V squared over P. 120 volts squared divided by 275 watts gives you a resistance of 52.4 ohms. All right, so there's the resistance of the television. Now a 12 ohm hairdryer is plugged into the same outlet, which means it's plugged into parallel. What is the equivalent resistance of the two appliances? Well, 1 over RT would be 1 over 52.4 plus 1 over 12. The common denominator there is 628.8. So you'd have 12 over 628.8 plus 52.4 over 628.8 gives you 64.4 over 628.8. Take the reciprocal, which would be 628.8, divided by 64.4, and that gives you a total resistance of 9.76 ohms. This makes sense. You knew that it had to be less than 12 ohms, and so your answer makes sense to you. That'll do it on problems. What do we got here? 32 through 35. More to come in class as we do problem 36 together tomorrow.